and welcome back to another REPL speedrun. Today, we're going to be starting on challenge 7.5 in lists, and we'll be getting up to 7.9. If you're not too confident in your lists ability yet, maybe check out my previous speedrun where I explain lists in a bit more detail, and some of the functions that we use with them. Okay, let's start with 7.5. Given a list of numbers, determine and print the number of elements that are greater than both of their neighbors. The first and last elements of this list shouldn't be considered because they don't have two neighbors. So, how are we going to go about this problem? To do this problem, we're going to be using a for loop and an enumerate again. So let's say our list L is equal to the input, and we want to loop over every element in the list that isn't one of the first or last items. So we can go for I and element, since we're using enumerate, in enumerate, and we want to get the list without the first and last items. That means we want to start at the first index and end on the length of the list minus 1, which is the last element. If you remember, this is inclusive, so we start on the first index, and this is exclusive, so we will end on the number right before the last index of the list. Right. So now we want to check if this element is greater than both of its neighbors. So how do we do this? Well, we can check by using an if statement. If element, and let's check if it's greater than the neighbor before it, which we can get by using li, because if you remember, this starts at 1, so at the first time we loop through this, I will be 0 because we're using enumerate, but the element will be the first element in the list, so we can use I. So, and then we want to check if it's greater than the element after it, which we can get by using li plus 2. And if this is true, we want to print the number of elements, right? So we want to make a variable before we start the loop. Let's say count, and we want to make it equal to 0. And every time we find an element that's greater than both of its neighbors, we add 1 to the count. Remember, this plus equals is shorthand for equals count plus 1. And finally, we want to print the number of elements, which is stored in our count variable, so we will just print count. So let's test this with the example input. As you can see, we have 15151, and these two 5s are greater than both of their neighbors. So we should get 2 if we put this into our program, and sure enough, we do get 2. So let's submit it, and just like that, we've solved this problem. Now, on to the next challenge. So, we are given a list of numbers with all the elements sorted in ascending order. Determine and print the number of distinct elements in the list. How are we going to do this one? So, what we want to do is we want to get these elements, each element, and once it's a distinct element, if we've never seen it before, we want to add it to a new list. So let's call that list C. And if the element, otherwise, if we've seen the element before, in other words, if it's already in this list, then we want to skip it. So for, say, element in L, which is our list, we don't need to use enumerate in this case. Now we want to check if this element is in this scene list. And if it's not in the scene list, we want to add it to it. So if element in scene, this is how we do it. So this in statement checks if this element is in this list. And if it is in the list, we don't want to do anything. So actually, we want to check if it's not in the list. And if it's not in the list, we want to append the element to this list. And what does append do? Append inserts things to the end of an array. So if we let's say we want to append hello world to our input list. That means we're going to insert the string to the end of the list. So if I just quickly run this code, and we have to put something in here so it won't error out. If I just quickly run this code, say we have an input list of 1, 3, append attaches whatever's in here to the end of the list. Okay. Anyways, so we want to append this element to our scene list. So scene.append element. And finally, we want to print the number of distinct elements. We find the number of distinct elements because that's the number of elements in the scene list. So we can simply print the length of the scene list. So let's test it with the example input. As you can see, we have 3 distinct elements. And so therefore our output should be 3. So if we paste this in, our output is indeed 3. Let's submit this code. And as you can see, we've got it working. Now, on to the next problem. We are given a list of numbers, and we want to swap adjacent elements in each pair. Print the resulting list. If a list has an odd number of elements, leave the last element intact. So, how do we do this one? And to do this, we're going to use another enumerate loop. So, in this case, we can use for I element in L, and the thing is we want to leave the last element intact. How are we going to do that? Well, we actually need to slice this list to get the length of L, whole number division by 2. And, well, why do we do this? We do this because this will round down the end of our list to the nearest index that's a multiple of 2. So if a list has an odd number of elements, it will leave the list intact, and that will be just fine. Even if it has an even number of elements, it will simply return the original number. Sorry, we have to multiply this by 2 again after. So it will return the original number, and we'll just get the same list. Right. Now we want to swap the adjacent elements. First, we can set the element at our current position, so Li, to the element in the next position. Actually, I've just thought of something. We actually want to skip every 2 elements because we want to get every pair in the list, not every element in the list. So, back to here. We want to set the element in our current position in the list to the element in the next position, which is its pair mate. And then we want to set the element in its pairs position to the element. Now, if you notice, if we set it to Li again, it will just get deleted because it will be the exact same because we've already changed Li. So that's where this element comes in handy, because instead of Li, we can set it to the element, which stores a reference of what was originally in the list, and it doesn't get changed even if we set the original value in the list to the value of its pair. And finally, we should be able to print the list. So here's our example input, and if we run this code, cannot unpack non-iterable int object. I forgot to put enumerate around this list. Whoopsies. Let's run the code again. And as you can see, oops, what's going on? 2, 3, 3, 4, 5. Right. So the thing is, we need to actually multiply I by 2. And the reason is we are jumping every 2 elements. So even though we'll be getting the element every 2 places, our index won't actually be going up by 2. So we can just have I times equals 2 right here. Let's put our example input again. And as you can see, we have the correct example output. So if we submit this code, it should work just fine. Now, we want to notice that if we ran this code again, it's actually outputting list. And luckily REPL accepts list as output. But what if we want to make this a string? If we want this to make this a string, we have to use a method called join. And what join does is it joins adjacent elements in a list by with a certain join parameter. So if we put L in here, and we want to join them with a space. As you can see, there's a space between each number, so we can put a space dot join L. And if we run this code, copy our example input in, and of course we have to convert L to a bunch of numbers. Sorry, a bunch of strings. So let's just put string wrappers around these. And if we try to run this code again, expected string instance int found, right, because of our last element. So we also want to change, just make sure the last element is a string. So we have L minus 1 equal to string L minus 1. So if we run this code again, as you can see, it's printed exactly as the output and not as a list. And if we submit this code, it should also work. Right, on to the next problem. So we're given a list of integers, find the first maximum element in it. Print its value and its index counting with 0. So for this, we are also going to use an enumerate loop. If we think about it, we want to use a for I element in enumerate L. But first, let's create some variables. So we need to print its value and we need to print its index. So we should create a max value variable, which we'll just set to 0. And we need to also create a max index variable, which we'll set to 0. And so when we enumerate through this list, first we want to check if the element is greater than our max value. If it's greater than our max value, it means it's a larger element. And so we want to set the max value to the element. And we also want to set our maximum index to the I. And if you notice, this gets the first maximum element because even if the element's equal to the maximum value, in other words, it's like the second or third maximum element, this won't update. Finally, we want to print our max value and the maximum index. So let's test. We have 1, 2, 3, 2, 1. So therefore, we should print 3 as the maximum value and 2 as the maximum index. So if we run this code, as you can see, it does print 3 and 2. So let's submit this code. Oh, what's wrong? As you can see, we've made a slight error because we've assumed that the maximum value has to be greater than 0, which is not the case. So what we want to do, instead of setting the maximum value to 0, we want to set the maximum value to the L0. So just in case the first element, well, we'll set it to the first element and we'll go from there. And as you can see, this code works perfectly. So let's wait for it to finish, and we'll move on to the final challenge. So, given a list of distinct numbers, swap the minimum and maximum and print the resulting list. So, this is very similar to the maximum challenge, so honestly, we can just copy a lot of this code. And instead of just finding the maximum value and the maximum index, we also want to find the minimum value and the minimum index, and we'll set that to L0 and min index equals 0 as well. And so if the element is less than the min value, then we want to update the min value to that element. And we want to change the minimum index. Sorry, I've not changed it here. Min index is equal to I. And finally, we want to swap the positions of the maximum value and the minimum value. So at the very bottom over here, we can say L max index is equal to min value, and then L min index is equal to max value. And then finally, we can print the resulting list. We'll just be printing it as a list, but as I showed you earlier over here, it's possible to print it with spaces as well. So our example input has 3, 4, 5, 2, 1. 5 is the maximum and 1 is the minimum, so we want to print 3, 4, 1, 2, 5. Let's see if our program does that. And sure enough, it does exactly that. So if we submit this code, ooh, what's wrong? 2050, I wonder. 2050, 10, 30. So it's detected 40 and 70 as, and that's because we have not, well, we've made a mistake. We need to put minimum value here, not maximum value. Let's try again. And as you can see, our code works perfectly. So that was the end of the simple list challenges. Next, we'll be moving on to some more advanced and complicated lists challenges, which will test your skills that you've learned here. See you there.